Welcome to Zaptiontor 5.8, Graphing Absolute Value Functions. This is a short lesson. There's only 4 boxes. The essential understanding is this. You can quickly graph absolute value functions just by shifting the graph of y equals absolute value of x. So we're going to be talking a lot about the absolute value function as we begin this lesson. Box number 1 is the absolute value function itself. In case you're not familiar with it, we need to actually remind ourselves of what it looks like. Okay? So I have a little table set up for you. Let's just do a little investigating on our own. I'm interested in the absolute value of x, and the way that we represent that is with these little bars, these vertical bars on either side of x. And it means a positive distance from 0. So if I plug in the absolute value of, say, -3, well, the absolute value of -3 is a value of 3. So the coordinate point would be -3, 3. This point would have to be on the graph. And likewise, if I fill this in, -2, I'd get a value of 2. So -2, 2 would be on the graph. Likewise, -1 would give me just a value of 1, so -1, 1. Obviously, the absolute value of 0 is just 0. And then I get the same thing. Well, this is just going to be a 1, a 2, and a 3. So 1, 1, 2, 2, and 3, 3. So you can kind of see that there's a pattern being done here, and it's making this sort of what I call a V-shaped graph. It's called a V-shaped graph. So the true actual graph would look like this. Here is the absolute value of x. I'm going to go ahead and graph it for you. And obviously we get the exact same thing over here. So as you can see, no matter where I go, right, this thing is just a V shape the entire way. So that is an introduction to the absolute value function. Box number 2 is called vertical translations. So take a look at the function I have here. I have the absolute value, y is equal to the absolute value of x plus some a value. And right now the a value is set to 0. So I'm going to go ahead and graph this for you. And we would obviously see just the regular old absolute value functions. But watch the graph as I move the value of a from 0 to 1. What did you notice? Hopefully you noticed that it went up 1 unit. If I go to 2, it goes up 2 units. Here, let me make this a little bit so you can see each of the changes as we go along here. So even if I move this all the way to 5 units, well, it's just the absolute value graph moved up 5 units. So what would happen if I go the other direction, right? If I go back to 0, if I say -1, then it moves it down a unit. So adding a number on the end of your absolute value function will move it up or down. So vertical translations for box 2, like as an example here, f of x equals absolute value of x plus 3. Well, this red graph that I have is the absolute value of x. And this blue graph I have is the absolute value of x plus a 3. Notice that each point has been moved up 3 units. So given each point, it's been moved up 3 units. So from here's the original 1, 2, and then 3. So vertical translations, when we add or subtract a number on the end of our function, will move the graph up or down according to that many places. Box number 3 is all about reflections. So here, I'm going to graph the original absolute value of x, and then I'm going to graph the negative absolute value of x. So notice what happens to the graph. Well, it's been reflected over the x-axis. Every single point on my graph, right, has been reflected over the x-axis. So if I consider this point right here, -6, 6, now became -6, -6. It's just been reflected over the x-axis here. So this is box number 3, and it's all about reflections. So every time you see the negative in front of your absolute value function, it's going to reflect it over the x-axis. Finally, box number 4 is all about horizontal translations. So I'm going to go ahead and graph the function absolute value of x plus a. Right now the value of a is just set to 0. So when I graph this, I should see my original V-shaped regular old absolute value function, okay? I'm going to try and center the screen for you. So here's what I'm going to do. I'm going to move the value of a from 0 to 1, and I want you to notice the direction that the graph moves. So if I go from 0 to 1, notice that the graph moved to the left 1 unit. If I move, I'll go back to 0. If I move my graph from 0 to 3, notice the graph moved 3 units to the left, even though I moved it a positive 3 directions. I'll go back to 0. If I move it in the negative direction, if I make a, say, -2, notice that the graph moves to the right 2 units. So it's the opposite direction of what you might think it would be. Okay? So as an example here, if I showed you this graph, the absolute value of x minus 7, we would expect this graph to be the absolute value function moved 7 units to the right. So let's look, and look, here it is. It has been moved 7 units to the right of 0, 0. So there it is right there. If we compare that to the absolute value of x, as you can see, it's been moved 7 units to the right. So it's the opposite direction you think it would be. So here we go. Box 4 still horizontal translations. If I was going to graph this function as a quick sketch, I would make a coordinate plane. I would give myself the absolute value function right here, absolute value of x, and then I'd take a different color. Now I would go 5 units to the right, 1, 2, 3, 4, 5. So here would be the point 5, 0, and I would have this graph would be the equation absolute value of x minus 5.